Hello, my name is Jakub Pastuszek. So today I would like to talk about connecting Rust to databases with ODBC. This is sort of a project that came out of a need at work, and I did some work on this. And I would like to basically today talk a bit about the background of that work, also continue on to what are the crates available at that time, what has changed since, and what contributions I made to that crate ecosystem, and also how this crate is actually working and how can you use it. And so let me start first with a bit of a background story. So at work, I work for a website. So we collect a lot of access logs, server logs, and application logs, which are kind of important to keep the site going and well optimized. And for that, we used to use a combination of different technologies. So Logstash for collecting syslog messages. So syslog is used to kind of transport the messages to the central server. ElasticSearch would be the database where everything was indexed, and then there was a Kibana interface for it to see some sort of in a real-time fashion what's going on. And also we used Hadoop with Hive. So that was Hive on Spark to basically daily pull data off ElasticSearch and do some analytical queries and reporting that were needed to be done on the access logs and things like that. So this ended up to be quite expensive for a small site. I was in, my main project was to basically reduce the cost of the hosting. So I looked at this and and was trying to find a solution that would bring everything into a smaller kind of tidier system that was more appropriate for the size of the company we had. And also there would be lots of issues with this setup, and the complexity was quite of a problem there. So I came across this database called MonetDB. It's from a university in Netherlands, and the guys were working on this for a while, and these days try to make a product out of it. But basically, it kind of does what I needed to replace all of the things from the previous slide. And most importantly, it's not written in Java, but in C. So for me, this is, I kind of learned from this experience that Java is not very well suited for any heavy data lifting, mostly because of, obviously the garbage collection is a problem, but the more important thing is that you have to go through serialization, deserialization whenever you read data out of storage. And with C, you can basically memory map stuff and just work on this directly. So this is exactly what MonetDB is doing. The other thing I learned, I need something that has a columnar storage model, because for analytical queries, this is just so much more performant, especially if you have logs that can be like access logs, can be like, tens of columns wide records, often very sparse with lots of nulls. So we want this to compress pretty well for optimal performance. Another thing that they have is support for native support for JSON, which is pretty cool because allows me to store data that I don't have a concrete structure predefined. So things coming from application logs and still have them accessible. Maybe the performance is not as good as if the fields were native columns, but it's there if I need to access this data. So the design there was to have data aligned into columns for the most common use case of visualization and reporting, and have these JSON fields available for some more cases where you need more troubleshooting and digging in. And also what's nice about it, it runs on a single server with low memory footprint, so you don't need like I don't know, in case of my previous setup, I probably have like 5 or 6 servers, like 32 gigs each of RAM. And here I just can squeeze it onto one 32 gig server and have it access like a year worth of logs from a memory mapped hard disk. So that's pretty good value here for me. And yeah, it can also manage lots of data with a very easy partitioning scheme. So I use daily partitions. Same I did actually for the other system. So I'm kind of used to this partitioning scheme, but here it's very easy. It's just you just add tables to a master table and you have everything done for you automatically. So that was nice, but how do you talk with this thing? So they offer basically 3 kind of drivers. So the MAPI is their library that they offer that you can use to talk to it. But obviously there wouldn't be anything written in Rust for that. So would require me to get the C API and wrap Rust code around it. So I wasn't too happy about that. And they also have JDBC drivers, but this is from Java world, so no good here either. But they also offer ODBC driver. So this is basically their MAPI wrapped around a driver that can work with Unix ODBC on Linux, which is what I'm using here. So I was looking for some crates that would let me access this database through that driver. And there were a few crates in there already, so I will show you in a second. Another thing that was quite convincing for me about ODBC is that with the old system, I do a lot of reporting when I connect to multiple different data sources. But in particular, SQL Server is the one that I was very interested in getting working as well. So having a single way of connecting to 2 databases from one program for the reporting purposes would be ideal. So what is ODBC? So it's open database connectivity. It's a standard that was designed by Microsoft. The first version was released in 1992, so it's very old actually. But it's basically an interface that makes possible, as you can see here in the description, to connect applications with databases with different drivers. So the application can implement a single way of using the interface, and then you can exchange the drivers depending on which database you want to talk, which is pretty neat. It's natively available on Windows, being Microsoft thing, but there is also support on macOS and Linux via this Unix ODBC library, which I used here. And has a wide support for different applications. For instance, Tableau comes to mind, has support for DBC, but basically there will be different, I think Excel would be able to use that as well, etc. So being widely supported means that database management systems, basically their developers make sure that there are ODBC drivers available. So there are many options when using ODBC available. So Unix ODBC, so this is definite standard for DBC on non-Microsoft platforms. So that's how they brag about on their main site. Basically, it's an open source project that implements their API and allows drivers to be used with that on basically non-Windows platforms. There are 2 configuration files you would have to look into. One is odbc inst.ini, which where you configure the drivers, and the other one is odbc-ini, where you configure the connections using those drivers. And then the main thing is the connection string, which is basically as you select a driver and give it a list of parameters in one string that allow you to connect the database. So for instance, username, password, and database name would be the most common ones. But you can also configure this in the odbc ini and then just use the name of the connection to connect to. So I'll show you later in examples how that looks like. So the state of the crates has changed since I did the project. So I will, there's a new crate there, but when I started, there basically was odbcs by Konstantin, and this odbcs is the kind of low-level unsafe types that basically represent the C API of the odbc version 3. And then he also provided a crate that was a bit higher level and was supposed to be safe, that uses this low-level unsafe library, but he wasn't very happy with the safety of it. So he made another attempt, which was called odbc-safe. And basically that was it. And now, and there were also a few contributors apart from Konstantin, but I'm just noticing him because that's his repository. And there is also Marcus Pacman82 that recently created odbc API, which tries to learn on the mistakes of the odbc and odbc-safe. So what I've used here was odbc, because odbc-safe wasn't really there yet with the features, but I got it working. So let's continue. So odbc-iter is the, so I basically contributed a few other crates around odbc-iter, but the main one is odbc-iter. And the idea here was to create some an idiomatic high-level library. And so by idiomatic, I mean using things like iterators and type conversions and things like that that you would expect from a Rust library. And has the name iter from iterator. That's how it started. There is also odbc tools, which is basically a simple set of CLI utilities that are built on top of odbc-iter, which can be handy for querying, doing some ad hoc queries from scripts, and also for testing the iter thing. There's one called odbc-avro, which I've released because of part of building the system. I needed something to do backups, and I use avro format that would be stored on S3 as an archive of all the data. And so basically avro would give you, this crate would give you a tool and the library to generate avro format out of your query result set. odbc init schema is another thing that I released as part of my project, where where it has some utilities to work with schema changes and things like that. So why did I create odbc-iter in the first place? So there's some requirements I had at hand to make things going for the new project, and mostly because I wanted to have a nice and safe and idiomatic way to work with the database. And there were like 3 main components of the new system. One is the syslog message processor. So basically it would take syslog messages, process them somehow, and then insert data into tables using a prepared and parameterized queries for optimal performance, and also would book them up into bigger transactions. And in my case, it's either 1,000 rows or 1 second in time elapsed, whichever comes first. So it's still quite real time, up to 1 second, and but has this property of not making very short transactions. And also I needed to be able to back it up. So basically fetch data from MonetDB and stick them on S3, and that's why I use Apache Avro here. I guess these days there is a bit more movement on the Parquet side of things, so and that was the format I used with Hadoop, but Avro was something, there was a library I found working well enough for this purpose, so that's what I use here. There is also another component, is Grafana JSON data source. So for real-time visualization of the traffic and other things, I use Grafana, and Grafana has this nice connector, kind of database agnostic connector, I should say, which basically talks with JSON to an API server. So I've implemented such a server that basically queries MonetDB based on those JSON messages and replies back some data sets, data series or tables for visualization. So for this, I actually did an ad hoc, or as ODBC calls it, direct queries, which are built based on the request from Grafana. And also I needed multi-threading because I wanted to be able to issue multiple queries for a whole dashboard. So dashboard would have many elements and they would all generate queries. So I wanted them to basically work parallel, so to have a dashboard load quickly. Another kind of requirement for that was to be able to do reporting jobs. So typically also ad hoc queries that would be quite complicated, and luckily MonetDB supports a lot of the SQL standard, including windowing and aggregations, custom aggregations in windowing and stuff like that. So you can basically run any complex queries you want on it, the data. But there was also a problem here that I kind of discovered later, that there is a difference in the way that the encoding is done on strings, and MonetDB uses UTF-8, while SQL Server uses UTF-16. So obviously I had this requirement that I have to be able to support two different encodings in a single running program with two different connections going to different databases and have them to exchange data. So this is an example of ODBC library usage. And this is basically what's going on here is this direct query from SQL text. So SQL text has some SQL query, and you can see how getting data is done here. So basically first you need to get the number of columns you have, then you need to fetch a row, then you actually get a cursor and then move the cursor column by column to get data, and you have to specify what sort of type there is. In this case, it's str, and then it might be a null, it might be an error, etc. So, and there might be no data. So as you can see, this is a bit of work to get a row. So this is an example from odbc-iter. So you do the same direct query. So this is a text here. And you can see mainly two different things. One is that I give a type of the whole row in a query, and I get a tuple of string and integer in this case. And also that the result of the query call is an iterator, and I can just use a for loop, or you could also use normal iterator adapters like skip, take, etc., and zip, and what else. And apart from some error handling, this basically, what it basically does is runs the query using iterator and make sure that the types, data types, the row is automatically handled for you. So a bit about initialization. So ODBC, there is this concept of environment, which you need to initialize before you can use the library, and this basically comes from the C side of things. And it's important you can only you must only initialize it once and only once. So if you do it twice, then it's an undefined behavior. So I use lazy static create to make sure the library is optimized only once. So if you don't know, lazy static is basically a way to run code on the kind of on demand only once, and have it to be in a kind of global static. So the problem with, the problem with Rust, or the design of Rust, is such that they try to avoid a problem of life before main, as they call it in C, C++. So Rust does not allow you to run code before the main function actually starts. So as a workaround, let's say you can use lazy static to be able to create a static global, but also have some code run, but that code will be run on a first use or first access to it. So that's pretty handy. Obviously, in the newer versions of Rust, you can also run some code that is kind of const compatible code, but this will be actually executed by the compiler's compilation time, and only the result will be used, and that's not applicable for this sort of use case. There is also a way to actually use a function to make this initialization explicit in the code, which is handy when a HTTP server is set up. So you can run it before any request comes in to make sure that things are working. And here's an example how to connect a database. So as I mentioned, I use connection strings to do so. In this case, I just take it from an environment variable. Actually, I may not have an example here of one. But anyway, to connect, you just pass this connection string to odbc connect. And as I mentioned, this will initialize the library with the lazy static thingy, and if it's not initialized already, and then make a connection. Additionally, what you need to do is before you can query, you have to take a handle, and the handle is a reference, a mutable, like it mutably references the connection, and it has a use in here for making sure that actually I can explain it here for making sure that the connection, that the iterator or the result set that we iterate is consumed before you can make another connection to avoid errors. There is also an unsafe function called new concurrent, and the idea here is you can create connections in multi-threaded way, but this assumes that the underlying library is capable of like this being multi-thread safe when making connections. And I learned the hard way that SQL Server does not like that. The driver that I'm using under Linux, and basically you have to make sure that you connect only from one thread at a time. So by default, it will be managing this through a mutex. But there is an option for MonetDB, you can use this unsafe one. And here basically declaring that your driver can do this safely. There's also settings where I can connect with a connection string and also set some things. And in this case, I'm using this to be able to configure encoding of the connection of the strings, which is handy for SQL Server. And as I mentioned, that handle also plays a role to statically ensure things are used in correct order, and also plays a role with prepared statements, which have to kind of outlive any query, and so that's why it's there. And a little note on this encoding. So SQL Server, so both the text of the SQL and the responses, the I guess varchar or w varchar, whatever what have you there, they would be UTF-16 encoded, which means they use 2 bytes instead of 1 for every character. So this is handled by odbc-iter by encoding or transcoding the queries to UTF-16 before they are sent, and also to transcode the string types into Rust types into UTF-16 types. And it also works if you don't specify that the database is UTF-16, then everything just works as usual with an assumption that everything is UTF-8 encoded. Obviously, some databases may use some code pages and stuff like that, but that's something I do not support here. So working with ResultSet. The the main object you interact here is this result set, and that's the thing that implements the iterator interface. And that's what you get from different ways of executing queries. And because it implements iterator trait, it can be just used in loops, and each item is a row of the result. You can also ask it for various things, like you can get an associated schema, which will be a list of columns, their names, and the SQL types that they have, which is quite handy when doing things like dumping a table into JSON object format, for instance, or for Avro format as well. Also, it supports the type conversion as part of the interface, and it uses, I have created 2 traits for that. One, the try from column, is responsible for decoding or for asking the ODBC driver for the right type for the right Rust type. So if you ask for string, it will try to get a string out of the column. If you ask for, say, integer 32, it will try to get an integer column value from the result set. And then try from row represents the whole row, which is what you get in the end. So you can, for instance, implement that for. Now I'll talk about this actually later a bit more in details. It provides also shorthand functions, which are quite useful, like single, first, and no result. So single is when you expect only one and exactly one row of response from a query. And if that's not the case, then you're gonna get an error. First is when you expect at least one row, and no result when you expect no rows in the response of your query. And this is handy for things like inserts, deletes, or updates where you get no result, just to verify, like just to make sure it's checked for you. And then obviously you don't iterate the result set, you just get the value out straight away. And also the result set can be closed to obtain the prepared statement, which I will talk about later. But basically, when you have a prepared statement, you want to be able to reuse it later on. And then it also may have information how many rows were affected by the query. So some database report, for instance, how many rows were deleted by the delete statement or updated by update. So a bit about this type conversion. So as I mentioned, there are 2 traits that are defined and that are implemented for various things for you, but that you can also implement yourself for your own types. And basically, I have implementations for relevant Rust types. So there will be signed integers, because that's what you get from ODBC. So for instance, I8 would expect the result to have something like tiny int on the SQL side of things. I32 much integer, I64 would be big int, etc. What is important to note here that I wanted to make sure that there is one-to-one mapping between those types in Rust and in the result set. So if you ask for a wrong type, so for instance, you query a string, but you ask to get a row of type in I32, then there will be an error. So there won't be any implicit conversion done by either odbc-iter or the driver, which could be a case in, I'll talk about that later a bit. So I'm just trying here to be a very kind of one-to-one strict mapping between those types. Also, I support, and this try from column is also implemented for an option of anything that implements try from column, which basically means that you can get nulls as well handled this way. So if your table contains nullable columns, then you want to use option type for the rows type. And there are a few optional features that I've added. So I've added for handling timestamps, I've added support for chrono types. So chrono is a kind of date time library for Rust, which is very popular and quite powerful. And basically, you can get chrono types straight from the query. So for instance, if you use date times and timestamp, all of that is implemented. There is also an optional feature to enable decimal. So that was actually contributed to me, and it uses Rust decimal crate to represent decimals on the Rust side. The implementation is, let's say, it's a bit hacky because it just uses goes through some string representation to get those in, but it does work well enough for what I needed. So I made it an optional feature, but it might not be the very performant way to do things, but you still be able to query tables, like select star from something that has decimals and have a good result out of this. There's also a way to query JSON data, which I tested only with MonetDB because that's what I needed. So in MonetDB, you can have JSON columns, and they would be basically a bit like string columns, but the database will verify it's a valid JSON, and it will let you do some things like accessing with a path, accessing values, giving a path, for instance. So this is very nice. So if you have this feature enabled, you can get a JSON value from the JSON crate, and you can work with that further. And yeah, and then obviously I have to implement some way to get the whole rows of those types. So I've implemented the try from row for tuples of different sizes up to 25 items. So if you have table that is wider than that, you might be out of luck. But given some work in Rust with the const generics, it might be possible to have a generic implementation these days rather than having to have macros to generate all of those sort of manually or kind of semi-automatically. And as I said, I've tried to avoid using the driver to convert types, because that's what ODBC kind of supports. Is like if you get an integer and ask for a string, then the driver can render the integer into a string for you. But then it depends on every different driver may do different things. Some drivers may not support some of the conversions. And basically, I found this to be rather buggy and complex topic. So try to avoid this altogether. What you do instead, you can use cast in the query to make sure that you get the proper type out of the database. Or you can basically do the casting on the Rust side as well with different tools we have here. Okay, so a bit on dynamic typing. There is also a support for a type called value, which is a bit like JSON assert value, in that it can represent any of the SQL types that I've implemented for it. So that should be most of the basic types you can expect. And the idea here is that you can ask for value instead of a specific type. And then at runtime, you can figure out what actually you got. And then there is also a value row, which is a similar thing that basically is a vector of optional values. And if you query for that, then you can basically query for anything you want. And then at runtime, you can figure out what that actually was. And this is very handy for writing tools. So I mentioned that I have these tools, ODBC tools, create as well. And then there is a generic kind of query tool, which can output in various formats, including JSON. And this uses that exactly so that you are able to specify any query as a command line parameter, and it should just work and and basically handle any format of the table or any set of columns that the database will return at it. So I also added with Saturday feature value and therefore value row as well can be serialized. So again, this is very handy for like dumping things as JSON or as anything else that Saturday supports. So here's an example of how to use prepared statement. As I mentioned, I needed that for inserts. Actually, here's an example of a select statement. The idea is that you can execute it, and then in the end, you can get it back with a clause from the result set. It's not on the screen here. But, and here I actually use the value row as an example of how to get the data. So the idea with these prepared statements, for those of you who don't know, is you can send the text of the query to the database, and database basically prepares for its execution by basically building all the query plans and things like that. And that database sends you back its an ID. And then when you make a query, you just use the ID saying, please execute this. And this is pretty handy for things that you know will be repeating a lot, like those insert statements I mentioned. And you can even sometimes get some schema information from your query if that was possible to be inferred from by the database. So yeah, so you get the performance benefit here. There's a bigger example here using parameterized statements. So with prepared statements and a normal ad hoc or direct statements, you can also use parameters. And the idea here is that instead of values in a query, you put a question mark. And then what you can do is you can bind values to those question marks. And this is done with execute with parameters here as an example. Here I bind a string and an integer and another bigger integer. And you can see you can use Rust types, you just reference them. The important thing to note is obviously because they are references, you need to keep them around until you consume the result, until you actually, your query is executed, but this is all handled statically by Rust compiler, so there's nothing you can do wrong here, at least in theory. And as you can see here, I iterate the result set, but what I do here, I use a mutable reference to the iterator, so I can later close this result set and get my my prepared statement, which can be parameterized with new set of parameters again. And you can see that what we get from the database is a string, an integer, and some big integer. So the database automatically chooses the right type for the values I got and sends them back. So what's the benefit of that? Well, obviously, if you have parameterized statements, it's not very useful to be able to run only one query. Sorry, the prepared statements. So prepared statements that are parameterized is what is useful, because then you can actually give it different values and have it sort of templated out the query for you. But also what it does, it prevents SQL injection. So if you have untrusted data and you put it as a parameter instead of just concatenating strings, then they cannot escape the syntax and run some other things. And also they are more efficient at transferring numerical data because it's all in binary rather than in text. Yeah, as I mentioned, you can use different types that are supported by the library to be bound as parameters. Another aspect that was kind of interesting here was the multi-threading aspect. So that's a bit tricky here because the multi-threading story on ODBC depends on the driver at hand. So one driver may be thread safe with this regard of these operations and not thread safe with that operations, etc. And there is sort of no programmable way to get that information. So you have to work with some documentation and work it out how it works in practice. So as I said, I had to make some assumptions when designing odbc-iter about what can be sent between threads, what has to be synchronized with a mutex, etc. So that might not match what your actual driver does. And again, I'm only worked with these two databases primarily, so that's where this is tested mostly on. But also note that ODBC, the Unix ODBC library itself has different settings that you can change, and that changes the way that it synchronizes the drivers as well. So there is a layer of synchronizing primitives added by the library as well. So for instance, I had everything nicely parallel for the Grafana to query, but the results were surprisingly coming at the same moment on the screen. So I was kind of trying to figure this out, and apparently ODBC, the Unix ODBC library was synchronizing function calls on the function call level. So once the first query was waiting for result, then the others were waiting on the mutex to wait for the result. So once it returned, the others could return as well. And that was something I was kind of scratching my head a lot to figure this out. And apparently there is a setting which you can define which level of synchronization you want. And by default, it's sort of strict to, I guess, avoid problems. But you can relax it depending on the driver as well. So that's what I did. So another thing, how do you work with multiple connections from multiple threads? So to make things simple for my quite simple API server, I added this module called thread local. And the idea here is that the connection will be handled, will be created and then kept at the thread local level. So one connection per thread. And here is an example how you use this. Basically, you have this block that will be yielded a connection, and it's actually a result, so you can check if the connection was successful or not. And then you get the handle, and then you work away. And when you're done, you can return the connection, and it will be stored in the thread local and will be available for you the next time. Or you may decide to not to give it back in case, for instance, there was some errors and you want the connection to be re-established, to be on the safe side of things. Then you may just drop it somewhere and give it none, and then it will be established again for you next time you call the block. Yeah, so basically what I said. And this is very, yeah, this comes very handy for a kind of simple thread pool based HTTP servers. You just need to make sure that the number of the threads are not sort of, you know, coming in and out. They have to be, because then you might be leaking those connections if the thread is deleted and a new one is created. So that's sort of a caveat here, I would say, but otherwise it works pretty well. And finally, there is some statistics module that can enable there, and it gives you some counters that add things up and can give you some idea. I use this mostly because of when I was troubleshooting this problem with multi-threading and things being blocked, and this came very handy. So current work and sorry, current state and future work on this. So currently I have this working in production without any issues, at least around this part. And I work with SQL Server 19 in 2019, and I work with MonetDB. So that's basically where the code is kind of debugged on, I would say. So it's been there for a while. So this crate I have not touched for a bit of time because it just works. But unfortunately, it's based on a deprecated crate right now on the odbc crate. So I'm assuming that if someone wanted to get it going with some new things or take it in different direction, then it might be a wise thing to consider rewriting that on top of the ODBC API crate, which is the kind of current one. I haven't looked much into it, so I don't know what how much work that would involve, but I'm guessing it's shouldn't be too bad, assuming all the features are there. Also, I was thinking about having this dynamic type handling for SQL types sort of moved into another crate, especially if you wanted to do this rewrite, then that would be in your way, and I think it could be a nice generic thing for others to use. And yeah, as part of this, you could also improve transaction kind of begin commit support, because right now I'm just hard coded, you know, what's the begin and what's the commit, which can be different from different databases. But there is ODBC handle for that, and it's a function that you can call, but it was not exposed on the version I think I've used back then. So that was some sort of a workaround. And yeah, based on all this experience with ODBC, I obviously saw a lot of things that could be better, especially going from Rust side of things. Yeah, so there's some list here, but the main problems I've noticed, like every driver has this set or the whole table of implicit conversions, sort of a la JavaScript, and the support for those conversions, like what you get from the database and what you ask for from the application, is different per the driver I use, and also it tends to be buggy because it's a very complicated thing for every driver to do. So I'm not sure why they wanted to have that, since you can convert on the query side with the casts or whatever you have on the database, and also you can convert on the application side. So having the third layer of type conversions, I don't know. So if I were to design RDBC, that would be thing that wouldn't be there, basically. Also, it's really like some things are really mind-blowing the way they do it with the memory kind of management. And for instance, a bug I fixed in ODBC crate was to do how parameters are bound to a query. So you can bound a parameter by using its reference, but in ODBC you also need to actually pass a reference to that reference, not just the reference. So it's double the referencing, and in order to do that, you need to store a reference somewhere in memory so you can make a reference out of it. So what they were doing, they were storing it in a vec, and obviously, as we know, vecs can reallocate. And therefore, if you added few more parameters, like you bound few more parameters to a query, this will happen, and those references to references wouldn't be valid reference, it would be dangling, and you would get crusher. So as a workaround, I used a vec of fixed size heap allocated with box arrays with 64 slots for the references, so that you could basically bind up to 64 parameters. And then if you bound a 65th, the vector would potentially like you would put another kind of bunch of them into the vector would potentially reallocate, but because those references were boxed, so would be stored on a heap, they were kind of pinned effectively and safe from becoming dangling. So that worked pretty well, and it was, while it's a major hack, it's sort of things you have to do to get these things going with those APIs, which are really like, I don't know what they were thinking. Also, the nice thing that they do in ODBC is how they handle splitting large strings. So if you get a large string from a query, it may not fit in some buffers, and therefore need to be fetched in parts by doing multiple calls and moving some pointers and some numbers around just to get all of it. The thing they decided to do is that each part, the driver when sending a part, so the database when sending, actually the driver when sending the part to your program, will add a null termination to it. So when you try to reconstruct it, you have to remove this null termination. Otherwise, you're gonna have bit of string, null, null, etc. And this will basically corrupt your string pretty well. So not only the driver has to add this every chunk, you also have to take it away. So I don't know. Again, I think they were just because it was C, it would be easier to debug it because you could display a part of a string, but I really don't know what they were thinking here as well. And thing gets really funny because when you use SQL Server, it's not one null, but two nulls. And that's because it's 2-byte encoding of the string. So I also made a patch to ODBC to detect the case where the encoding is 16-bit, and therefore you need to now chop 2 nulls before you put another part of the string into the buffer to construct the final large string. So yeah, also these problems with 32 versus 64-bit drivers, you know, coming from 1992, it went through some of these bit changes, and the legacy is there. There are lots of legacy data types there. As I said, the string encoding is specific to a database. It's not standardized. There is this multi-threading support is totally undefined, and depends on the documentation. You have to read somewhere to figure out what's safe and what not. There's this auto commit mode, which is kind of a weird thing. And you with the parameters, you can't really pass a table or an array of values. You can only pass single values, which is a problematic for joins and in clauses where you just want to say, join with these IDs or have in clause and with these numbers. So that's a bit limiting. And there people been very, I mean, I don't think it's ODBC specific per se, but I know like in C#, for instance, people be very inventive how to send a lot of IDs, for instance, for an in clause or for a join, and they've been using like XML to encode them and then send the XML value, and on the query side to just kind of loop through it, and it's just crazy stuff. And obviously one of my kind of things that I wish would change in the industry as a whole is like we shouldn't be using strings for the text for the queries themselves, because it's like a lot of strings we are using every day to send this in and out to the database. I would say that we should be using some sort of encoded data types like data log in JSON or something like this. So anyway, it would be nice if someone had enough guts to sort of try this in Rust. Something what I guess happened with Java was when Java had this RDBC standard they made it an universal driver that would talk with ODBC, with any ODBC, sort of a bridge. And then after some time, I guess more drivers appeared to be native JDBC, and it is now de facto standard as well, at least for anything Java. So I don't know, we'll see how this goes in Rust. And yeah, that's it. Thank you very much. Here are some links you can reach me with or through. And if you have any questions, I'm here to answer them. Okay, thank you again.
Yeah, David here. So how does this compare to Diesel, which is kind of a platform to create these queries and query database? And
yeah, as far as I know, Diesel only works with Postgres SQL, right? So they must be using their driver, and it's probably not ODBC driver that they are using there. So I mean, if they could use ODBC, then they would be able to use other databases as well.
I think Diesel supports 3 databases. So Postgres, Postgres, MySQL, and SQLite.
Yeah, so I'm guessing here, but I read about Diesel some time ago, is that they would be using some dedicated libraries for each database. So there wouldn't be any common interface like ODBC tries to present. And you would have to add, any database you would like to use diesel with to diesel, which is a problem.
Okay. Thank you.
Yeah, it's the same story with SQLX. They also got their, Postgres, MySQL.
Yeah. So that's kind of nice, like Microsoft in 1992 saw this problem.
But would it not
Try
be
to solve
possible
it,
to,
but yeah.
like, so sort of seems like we reinventing the wheel, because Diesel gives you all those abstraction layers to create queries and all that stuff, and then is able to tap into whatever database driver we want to use. So
Yeah, that
would
would
it
be
be
ideal.
possible to, add an adapter for ODBC at the bottom of Diesel, so then you support?
Yeah, I would say, yeah, I don't see why not really. Yeah, I would say that would be possible. Because in the end of the day, at least how I understand Diesel is that it's mostly about generating SQL, right, for you, and then yeah. So I don't know, if there would be any obstacles there, but it should be possible in theory. Yeah, because what I do here is, I do this type conversions and basically making it into iterator, and basically it accepts any string as a query and you can bind parameters. So in theory, I don't see why that wouldn't work. Yeah. But as you obviously note, the reason why they probably didn't do it is because, this stuff is just nowhere near ready for something like Diesel. I would say would be a bit, when Diesel started quite some time ago, possibly there even wasn't any libraries for RDBC at that stage. And, I guess you can get better, maybe less problematic, maybe those Postgres libraries are better quality than all this can ever be, I guess.
Okay, thanks.
Yeah, one thing I kind of noticed, which is sort of a pattern in Rust, is that while Rust lets you, in theory, talk with C, that only works so far and with kind of simple things. And when the things become as complex as ODBC with multiple states and different ways of doing memory management and some global things, then mapping between this C thing, which is quite messy in nature because there is nothing stopping it from being messy, into something that is rather clean and well defined on the Rust side. It's sometimes difficult. That's why you had like three attempts here to do it, and the ODBC save was an attempt to make it perfect in a way that every state that ODBC C library can have would need to be represented in the type system, but this ended up to be near impossible because those C libraries, because of their kind of relaxed design, tend to make this type explosion thing to happen. And if you try to make one-to-one, I think you may have a hard time. That's what the ODBC API tries to be less ambitious about, trying to map everything and just map the kind of useful subset of it. And I guess, with Diesel, yeah, I guess they probably didn't want to deal with that. They just took the best library they had for Postgres. I think they started on Postgres. But then in the end, you end up in this place where, yeah, why can't you use this database or that database? Why do we have to have this problem that, you have n number of libraries that generate SQL, and now we have to implement n number of drivers for them.
There's one from Shane here. Were there any major bottlenecks piping all production logs into Elasticsearch and running queries on them later?
Yeah, so the problem with Elasticsearch, like there were two problems here mainly. Let me go back to this slide. First of all, we used Logstash, which was not super performant, let's say. Also, to be fair, the system evolved over time, so it was not very optimal either. The amount of data I collected and the shape of it was not very optimal. But Logstash being basically Ruby on Java, I needed like 4 CPU server to kind of process, say, 200 messages per second into Elasticsearch. And the problem with Elasticsearch is basically that the moment you cannot fit the data in memory, like the kind of active working set, then you get into trouble with performance and with things running out of memory. So in order to kind of keep 2 weeks of logs viewable in Kibana, I had to use like, I don't know, 32 or 64 gig machine just for that. And then obviously I moved data to Hadoop, and then there was this mapping between this messy JSON into something table oriented. And that was a kind of headache as well. So I wanted to make things like running off one technology ideally, which would make, you know, one database server 32 gigs, let's say. I don't know, I think I have like 8 cores there, and it does everything. And it only uses like 5% CPU or something like that. So I reckon, again, the caveat here is that I actually optimized the data I'm collecting for the way of processing, but it's like 20 times faster, this setup I have. So I really just like use, I think you can do 1,500 records per second, and I couldn't do 200 back. And this 1,500 only uses one CPU because there is no multi-threading on the guy who inserts the data, because I never needed it. So.
Also, while using daily partitions indices for logs in Elasticsearch, did you come up with any smart ways of querying historical logs beyond querying each index sequentially?
Well, I used Kibana, right? So it automatically does this access per date kind of thing for you. So I was not playing with that, let's say. So what was handy though with this daily partitioning in Elasticsearch was that you could force unload a partition out of memory when you used it. So this kind of saved some RAM and made this a bit more stable for me because it didn't have to keep all the index and data around for some older days. But I know. Can you repeat the question? Just I think it was.
While using daily partitions indices for logs in Elasticsearch, did you come up with any smart ways of querying historical logs beyond querying each index sequentially?
No. So what I did, so Kibana did that itself, so I didn't have to mess with that. So Kibana can actually automatically sequentially query this for you. But what I did, every day I would take the previous day index and load it into Hadoop, into Hive table, and that Hive table would be a partition table. So when you queried Hive, you would query it as, you know, a year of data, let's say you had there. So I basically never queried Elasticsearch for the kind of for analytical purposes myself, so I didn't have the problem in the first place, let's say. If that answers it.
Okay, there's another question from D. Carlier. Is it still okay if we forget to call ResultSet close? I mean, even after usage. So I think this is when you're showing the code there.
Yeah. So the close thing basically, yeah, it's so what you have to do here. So normally when you use an iterator, right, like in this example, you pass it by value into this for loop, and basically it's gone after you can't call close or anything. It's basically consumed and dropped. So dropping this iterator is the same as calling close, and I think it's I'm pretty sure it's safe to close it even before you consume all the rows. But if you have a prepared statement, like actually in this example, and you can see here that I prepare it here, and then I use an iterate. I move it into this execute with prepared statement, which gives me the result set. And now I don't have it, right, because I gave it away. But here you can see that I'm using a a reference to the iterator, not the iterator. So this for loop will not consume it. It will just consume all the rows until it returns none. And then I can call close on it to retrieve the preparameterized, the prepared statement that I prepared here. And this way I can use it in another iteration and bind it again, etc. I don't have to call the prepare thing again, and I can just bind more new set of parameters. So this way I can keep reusing it. So what I do there in this processor for the syslog messages, I basically have some sort of a map where I have one prepared per daily partition. So if I have some older partition, I need to insert data to, and it's in a hash map, and basically I just check them out for a given day. If they are there, I use them. If they're not there, I create a new one. That's how it works.
Okay, so if you forget to close that result set at the end, by dropping it, it will close anyway.
Yeah, that's exactly what's going to happen. Yeah, it's fine.
Okay, cool. Static pictures. I think that means that. Well, thanks you, Jakob, for that great talk. If there's any other volunteers, we'll announce. Oh, hold on, there's a message here. Yeah, just thanking you. Yeah, so we will announce on the Rust Dublin Twitter account when the video becomes available. And if you want to get in touch with us for any reason, especially if you would like to talk, you have a subject you wish to make known to the public, then we'd be pleased to host you.